just give it a quick reset. And we've got 80 by 60 text. That's 640 by 480. It's nice and stable. Hi the lab. That's all the RAM I can get out of this thing at the moment. There's loads of testing stuff in the background. That'll be 1/4 of a meg as standard. This is a copper list, which we'll turn off. Copper lists basically just let you change any address in memory on any scan line. There's a wait command and a set command. Sort of like the Amiga, but way less capable. Like, it's just every scan line, not every 8 pixels. All file system keyboard and everything is coming across the serial cable. I have a little program over here, which is written in processing, which all it does is reads the keyboard and sends that down the wire and gets file commands and loads files. And directory commands. So cd demos. Okay, so I just typed that right. Yes, I did. So we've loaded up the basic file. And all it does is, I had to edit this file on the PC to put these control characters in there, but all it does is it just prints out the palette, which is 256 colors. The screen output's 32K, but this is a 256 color per cell text mode. This palette is stolen unashamedly from the 8-bit guy's Commander X16. So palette change. So all this does is it just changes the palette as fast as it can. Like, basic isn't the fastest yet, but I've never written one before. So it's just changing all the reds, all the greens, all the blues just as fast as it can. And you can see how fast it can go by the scan line gap as it changes colors. Oh wait, I've just actually realized that's 32 in basic instructions. So that'll just grind on for a bit. Tick tock, tick tock. Hello Discord. Oh, and it's finished. And this one here, 67,651 lines, and yeah, so it needs to be an order of magnitude better. But hey, it's just unoptimized. We're getting there. And we've got some sound stuff too. It uses over this side on the ESP32, there are, it's completely out of focus, there are 2 DACs. They're only 8-bit, but that's enough for this. And I've got a little interrupt routine that actually runs with the video, so every scan line mixes a sample. And then so the screen is 480 pixels tall, but it's not. It's actually 525 for the vertical scan. And in the vertical scan is where it fills up the output buffer for the next frame. So, load. Just playing with the sound generators, there are 32 of them, and the ADSR. Yeah, it's not particularly good, but PSG test or demo? No, it's test. Oh dear, hang on, that's wrong. Yeah, there's a typo. This needs to be focus, you friggin' cheap camera. This needs to be I+1. Or it will set the envelope of the first channel to off. Yeah, not the best. Let's try that one again. Okay, let's see. This one here is the official startup chime. I guess if you pause that you can see how the waveforms work, but this is the startup sound eventually. And this is running in 40 by 30 or 320 by 240 mode, 256 colors, plus the copper, which is unlimited. At the moment it needs a reboot, but I know how to fix that, to change the modes. Just haven't coded it yet. Oh goodness, I forgot about that. Trevor, couldn't be easier, just for little extensions. So it loads Trevor's palette to address 8000 hex, loads the palette from that, then it loads a raw image of Trevor into address 0, which it also turns the copper off first, because otherwise anywhere the copper's running on color 31, the logo, which is still running now, and anywhere color 31 will be on the picture will be a rainbow. Anyway, I have done a terrible thing. Oh no. So this is just 256 colors, 320 by 240, and my camera can't, my camera can focus that close. Except it seems to be flickering. Well, it's flickering on the camera, it's not flickering on the screen. But, yep, there we go. Right, so that there is bitmap data as text. Let's see. Dude. Trev 16. Same deal, this switches into mode 12, which is 320, 240, 32,000 raw colors, and it just directly loads over the slow serial interface. Okay, let's try that again. It loads a raw image of Trevor directly into VRAM at address 0, but it swaps the bytes. So it loads bytes 2 and 3, then 0 and 1, because this picture's got its words. Okay, let's try that again, because the camera just stopped recording. So yeah, this picture's got its words reversed, so it loads bytes, loads into address 0, bytes 2 and 3, and 0 and 1 for each 4 byte thing. And obviously this is very slow to load. Once it's in there, it can throw it around at tremendous speed if it wants to, but that's 32,768 color picture of...
The following message is transmitted at the request of the New Mexico State Emergency Management Agency.
We've got a 16 pixel tall character mode 2. This is the Atari ST font, I think. I could be completely wrong. Ha ha ha. Focus, right. Font. Whoops. Font 0. That was the first time, after programming, the first time the little typer connects to it, it reboots it. Serial reboot thing. So, yep, that's reloaded that logo from the font. We have... oh, look, it's DOS. This, I forget the name of this font, but it's a really nice one. It's a free and open source font. I have this is X Windows from like 1984, which looks lovely. This is just a little thin font, and I think that's it. It is, because this is an 8x8 pixel font that it's loaded into where it's expecting a 16 pixel font. But, okay, so if I've got the complete text of the Hobbit on here, just over 0.5 MB, and obviously the serial cable here, over the USB interface, it's only 115 kilobits. When I get the second ESP32, that's 160 megahertz. So that should be quite a bit faster for file transfers, but This is it's just a test command I added called view, which just views it. All this does is changes the color and views the Hobbit. It takes about 20 seconds per reading. So there you go, ladies and gentlemen, it's the Hobbit. Going just as quick as that serial interface will let it do its thing. And so that's that for the moment. The basic needs quite a bit added to it. It's, like I say, it's not the worst, and it's not the best, but I've only just started. It does, oh dear, yeah, the commands go up to about here. But it does Gary. 1000 Garys. We added this live the other night in the gallery. 1000 Garys. And this is with the copper, because, you know, that just runs. So yeah, it's been a lot of fun. It needs a lot more work. Ugh, you're gonna put speech marks around it, Aiden. It's basic. It's not DOS. Anything else? Dude, nothing specific. There's loads of test crap all over this thing. But yeah, lots more to do. Completely open source when it's done. Circuit boards get here Monday, so I get to actually properly play with keyboards. This is what the keyboard looks like. I'm super pleased with this. They're just cheap, like mechanical clone keys, Cherry clones, Cherry MX I think. Keycaps, it's like under $40 US for a set of keys and 5 printed sets of keycaps. I really like the colors. This is, I think it's 295 by 118 millimeters, 3mm thick plywood body. So yeah, more to do, and open source when done. Yeah, my line length is not going to win me any awards. This is part of the renderer that handles 80 column text out. These are all like lots of stuff on one line. No assembler, it's just all C. It's got to get it's got to look up the font, image, the color, and then make 8 pixels as fast as possible and pump them into the line buffer. Because, you know, there's 31,500 lines a second. You can't do it all. There's 640 pixels a line. Right, so yeah, loads more to come. This is just a test, so this isn't running in BASIC, this is all written in C, but it does multiple 256 color scrolling tile planes, plus loads of sprites. You can see the sprite renderer. This is back when it was written in, it was processing pixels 1 at a time, 8 bits at a time. It starts to drop sprite pixels when there's too many per scan line, but it's running in 4 bytes at once, 4 pixels at once now, because 32 bits are there to use, and you get about 2,000 sprite pixels a line now. It works really well. It should be able to get scaling, potentially rotation. Don't know. But of course you can run all of this from BASIC, just nice and easy, eventually.